Okay, so let's continue from where I left off. Okay, so basically now you realize hydrogen has two environments and carbon has two environments. So what does this all mean? It basically means this hydrogen will send out a frequency. Okay, let's say it sends out a frequency. All of these hydrogens will send out a frequency which is exactly the same. It's identical. Identical signals will be sent out. Meanwhile, these hydrogens will send out identical signals to the device. So their frequencies will be the same. At the same time, this carbon will send out a signal. This carbon also will send out a signal which is identical. And then finally, this carbon sends out a signal which is like that. Okay, that's it. So which means that is the number of signals which are released. So what will happen is, so if we look at hydrogen signals, right, in this example that I'm doing here with you, so what will happen is you will see a line like this. It will start at 0, it will end at about 15. This is called ppm. You don't have to worry about it. The first line here, right, this is the line for the TMS. Okay, so remember just now I told you TMS is added. Okay, I've deleted. TMS is added. The purpose of adding TMS is to tell us where the 0 lies. So wherever the signal for the TMS appears, that's where 0 is. Okay, so TMS basically indicates where 0 is. That's it. All right. So for hydrogen, it will start at 0 to 15 for hydrogen. So in the case of hydrogen here, you realize there were two signals only for hydrogen, right? So the red ones and the green ones. So what is going to happen is the red ones, the signal will look something like this. Let's say something like this. And then the green ones, the signal will be something like this. So the height of the signal, so there were 6 red hydrogens and then there were 2 green hydrogens, right? So the ratio is, what is the ratio? The ratio is 3:1. So the height ratio will also be reflective of that 3/1. So that's how the hydrogen signals will look like. So the ratio here would be 3 and then this would be 1. Meanwhile, for carbon, right, what will happen is, okay, so for carbon, the signals will look something like this. So it will start at 0, again, TMS, okay, but this will go up to about, let's say 220 ppm. So it's much bigger frequency. So for carbon, you notice there were 2 sets of carbons, right? Carbons A and carbons B. So what will happen is carbon A will produce a frequency, let's say something like this. And then carbon B, which was purple, will be something like this. So the height ratio of this will be 2 and this will be 1. Why? Because you notice there are 2 of the A carbons and there is 1 of the B carbon. So the signal will appear something like this. All right. So this is how we are able to read the signals for hydrogen and carbon. Let's do another example. Okay, let's do another example. Let's clear this page. Okay, so let's say we take another example. All right. Let's say we take this guy here. All right. Okay, this is called but3-one. Okay, this is called but3-one. Okay, butanone. So in this case, I hope you can see that there is a symmetry in the center here. If I put a mirror here, this carbon and this carbon are mirror images of each other. This carbon and this carbon are mirror images of each other. Okay, and that leaves us with this carbon, which is different from all 3 of them. So this also means that this hydrogen and this hydrogen and this hydrogen and this hydrogen are identical, and this hydrogen 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 are identical. So what does this mean? So if you have 0 to 15, right? So this first one here is TMS. So for hydrogen, TMS, for hydrogen, you will only see two sets of signals. One is the pink and one is the yellow. So pink is 6, yellow is 4. So the height ratio would be something like this. That means it would be almost like 3:2, the ratio. Because 6 to 4 is like 3 to 2. No? That would be the hydrogen signals. Meanwhile, carbon signals will be, so there are 2 yellow carbons and there are 2 pink carbons and 1 purple. So for carbon, it's going to be look something like this. So 0 to, let's say 220, 240, I think. And then this is TMS. So there are 2 yellow carbons, 2 pink carbons. So 2 yellow carbons. Okay, let's say 2 yellow carbons, 2 pink carbons, same height here. And then there is only 1 purple. So purple will be 1. So the height ratio will look something like this. 2:2. Okay, 2:2:1. That's the height ratio that you will get. Okay. So that is how you'll be able to read the signals for carbon. Okay. Now, let's say if we take the same thing, let's say this was butane 3-on, right? Now what I'm going to do is I'm going to take an isomer of this. Oops, sorry, cancel. I'm going to take an isomer of this. So let's say we take an isomer of this. All right, so let's say we do something like this. Okay, we do this. So this is butane, but 2-on. Okay, because this is 1, this is 2, so but 2-on. Currently, I want you to notice there is no symmetry, which means that I cannot cut the molecule anywhere here, which allows me to get 2 halves which look the same. So there is no symmetry. So this means that this carbon, this carbon, this carbon, this carbon, this carbon, they are all in different environments. Sorry, I missed this one. Here's a B, right? So all of these carbons are in different environment. So for carbon signal 0 to 220 or 240, you will get equal heights. Okay, equal height signals, 5 of them. Okay, equal height signals, 5 of them. So this basically tells you they're all in different environments. And you will get how many hydrogen environments? So there is this hydrogen environment, this one, and then you have let's say this one, and then you have this, and finally let's say you have this. So you also have 4 hydrogen environments, right? 3 yellows, 3 pinks, 2 reds, 2 whites. So for hydrogen, the signal will look something like this. Okay, so let's say 0, 15. So you have 2 yellows, right? Okay, let's say you have 2 yellows, and then you have 2 pinks, sorry, 3 pinks. So this one, the heights will be the same. And then you have reds, which red is 2, and then you have white, which is 2. So the heights will be something like this. All right, so the ratios of the height will be something like 3:2. So you get 4 signals, but their ratio of height is like is almost like 3:3:2:2. So 3:3:2:2. Currently at this moment, we don't really care where the signal appears, but I want you to understand that how the signal actually appears on the x-axis. All right, on the x-axis. Right. So we'll stop here for a minute, and then I'll continue with something else. So what I want to continue with is called splitting. It's called splitting. The n+1 rule. Okay, n+1 rule. So that's what I want to do with you after this. All right, let's take a short break.